Okay, today is our final lesson of Unit 6. We're going to combine Lesson 21 and 22 because they're very similar. It focuses very much on distributive property and equivalent expressions. That's the big takeaway from today here. And we've done a lot with distributive property. That should look very familiar by now. We're also going to need to remember order of operations and how we solve that way and when we're looking at these equivalent expressions. And we have to keep in mind what subtraction means in an expression. So subtracting something is getting rid of it. Adding a negative of that amount does the same thing. So keep all those things in mind as we kind of look at these equivalent expressions. For the first one, we have four different equations here. The first part of the equation is the same. It starts off the same. And they're all equal to something different here at the end. It wants us to select all the statements that are true. So would you take a moment, look at these four equations. There's only one that is false. So find that one and then we'll discuss. Okay, now with distributive property, remember when we have two outside parentheses here, like this, we're saying that there are two threes and there are two sevens. So we can't forget that when we're looking at what it's equivalent to. That means 2 times 3 and 2 times 7. This is a little bit different though because in front of it, we've got subtraction, which means everything here is being subtracted from 4. We're going to subtract two groups of 3 and we're going to subtract two groups of 7. So let's rewrite that real quick. So 4 is subtracting two groups of 3, 2 times 3, and we're subtracting two groups of 7. Okay, now you might think we want to keep addition going on here, but really that's not the case. We can combine this into one thing and subtract it all, but we can't just add this together because really it's all of this is being subtracted from 4. So that's what we need to find. So in this first example in A, we're subtracting two groups of 3, we're subtracting two groups of 7. That's exactly what we need. So A is good. B, here we're adding negative two groups of 3 and adding negative two groups of 7. That is going to have the same result if we're adding a negative amount. It's like subtracting it. So B will work as well. Now let's look at the differences here in C and D. So we have minus two groups of 3 plus two groups of 7, minus two groups of 3 plus two groups of 7. The only difference really is these parentheses. Okay, so we need to determine which one is going to do what we want. If, thinking of order of operations, addition and subtraction happening, we always work from left to right. So we would, in this case, after we've done the multiplication here, let's rewrite this and see if that would help. So 4 minus, we got to multiply first, so 2 times 3 is 6, plus 2 times 7, which is 14. So we're going to work left to right. We're going to take 4 minus 6, which is going to bring us negative, and then we'll add 14 on there. So that is going to equal, let's see here, negative 2 plus 14 would be 12. Now, if we look at the other way, and we work here in parentheses, we have 2 times, we got to work inside the parentheses here. 2 times 3 is 6, 6 plus 14. If we add that together, we get 20. So what we're going to do is 4 minus 20, which equals negative 16. Something very different. All right, but if we go back to the two that worked and we would solve these, we would find that they would equal negative 16. So this would be an equivalent expression because we're combining the two quantities that are being removed from 4. Here, we're not removing, remember we said we had to remove 2 groups of 3 and remove 2 groups of 7, but that wasn't the case. We removed 2 groups of 3, and then we added 2 groups of 7, which would not be equivalent. So this would be the one that would be a false statement. Okay, let's jump to the next activity. And that's, are they equal? Select all the expressions that are equal to 8 minus 12 minus parentheses 6 plus 4. All right, we could solve this to find what it's equal to. There's no variables in here. We could come to an answer, to a number here, and then see which of these are equivalent as well, which gives us the same result. But that's going to be the longer way of doing it. There's going to be a lot of steps in solving all of these expressions. So let's look for some similarities here. All right, in the original expression, we have subtraction, 8 minus 12, minus everything here in parentheses. So we're really only doing subtraction as we look at this problem. We're going to take 8 minus 12 and then minus some combination of 6 plus 4. So we could take away 6, take away 4, or just take away 10 altogether. And looking at the different expressions, I can see that right here is describing that. So we're taking away 12, we're taking away 6, and we're taking away 4. That is going to get us the same result. All right, let's look at some other ones. So no place in this would we actually want to add in a quantity. If we start with 8, we take away 12, and then we take away 10 more, we're just continuing to drop the value. We're continuing to subtract numbers. So if we're adding 4, that is not going to be equivalent. Here we're adding 4 again. No addition there. Here seems likely, but right here, this addition is a problem because we're going to add 10 as we solve this. So none of these addition expressions are going to be equivalent. We have to continue subtracting. Let's see if this one's equivalent. What I can see they did is they rearranged the order of some of the numbers being subtracted. So they're still starting with 8. They're removing 4, 12, and 6, which is what we did here. We removed 4, 12, and 6 just in a different order. Normally we would say you can't rearrange the order of subtraction, but since we're starting with 8, we're not really changing the order of subtraction. We are starting with the same quantity. We're removing the same amounts, just in a different process, in a different order. So this too would be equivalent. Okay, we're going to look at one last problem here. Then I want to let you give this a try. So, seeing it differently, some students are trying to write an expression with fewer terms that's equivalent to the expression here. We've got 4 different people here. We're supposed to see if anyone did it correctly, and if they did it incorrectly, then we need to kind of figure out what they did wrong. So, starting here, this is our expression. I can see we have distributive property happening here because we got 3 of everything in parentheses, and that's all being removed. It's all being subtracted. So we're going to subtract 3 groups of 4, and we're going to subtract, this is where it might get a little tricky. We're going to subtract subtraction. So we're going to be actually, instead of subtracting a negative, thinking of this as negative 9x, let's actually add 3 groups of 9x. So let's look at what Noah did. I worked the problem from left to right and ended up with 20 minus 45x. Okay, so work the problem from left to right. This is where he started. Working left to right means that he did 8 minus 3 first and got 5. The subtraction's done correctly, but that is not how we follow order of operations. Order of operations tells us before you do any subtraction, You need to take care of multiplying and dividing first. And we have multiplication happening here. This is 3 times everything here. So that is not going to be correct. And we'd say because of order of operations. Okay, next. Lynn said I started inside the parentheses. That's a good sign. And ended up with 23x. So in order of operations, we say you should start within parentheses. So if we're starting within parentheses here, 4 minus 9x, let's look at the next step that she wrote after combining that. She put negative 5x. Well, 4 minus 9 is negative 5. The problem is we can't subtract these. They're not like terms. Notice how this term has an x, has a variable with it. This one does not. So we can't do anything with it right now. If this was a 4x, we could do what this next step would be, but she did not subtract like terms. That's impossible to do. All right, Jada. Used distributive property. Good. Ended up with that. So let's look at her steps. Okay, distributive property. Distributive property is going to take this 3, multiply it by the 2 terms here in parentheses. So 3 times 4 is 12. 3 times 9x, we can do that. That's 27x. We're still subtracting, so we're good so far. Okay, so they've rewritten it. Now let's see what happened next. Next we go to 8 is having all of this in parentheses taken away. So they start by taking 12 away, 8 minus 12. That works. 8 minus 12 is negative 4. Then they're going to taking away 27x, or taking away negative 27x. Well, that's like adding 27x. So instead of subtracting negative 27x, let's just think of it as adding 27x. So this is 27x and our negative 4. This one is going to work out. That would be a good way to do that. And let's check Andre. I also used the distributive property, but ended up with a different answer. Okay, let's look how the answers compare here. So it looks like in this case, the negative, or the 27x is still being subtracted or thought of as negative. But that's not actually the case because we had 2 negatives. We were subtracting a negative. That's like adding a positive 27x. So this is not going to work out. This needs to be positive 27x. The negative 4 is okay though. So just a small error there. All right, that's where I'm going to stop. I want you to go to the back side of the handout and look at just a couple more examples. I'll have the answer keys posted so you can check your work and check for those equivalent expressions that you're finding. And of course, I would be happy to answer any questions that you have on Zoom today. Everybody have a great day.